Hello, everyone. I hope that you enjoyed the previous panel. Uh, we are joined by Professor Lewis Dartnell, and uh, he is the special guest speaker for today. When we talk about human history, we focus on great leaders, revolutions, and technological advances, and we have made our history quite human centric. But how has the earth itself determined our destiny? How has our planet made us? Our speaker for today will dwell upon these questions. So let me introduce to you our speaker for today. Professor Lewis Dartnell is an astrobiology researcher based at the University of Westminster, London, studying how microbial life and signs of its existence might persist on the surface of Mars. Alongside his research, he writes regular science articles in newspapers and magazines and appears in TV shows such as the BBC Horizon, Wonders of the Universe, and documentaries on National Geographic and the Discovery and History channels. Two of his works, Origins, How the Earth Shaped Human History, which he's going to talk about today, and another book, The Knowledge, How to Rebuild Our World After an Apocalypse, are Sunday Times bestsellers. So I won't keep you any longer from listening to our speaker. I welcome Professor Lewis Dartnell. Vedanti, could we have Professor Dartnell's video?
Hello, my name is Lewis Dartnell, and I'm very excited to have been invited to talk to you all as part of the 5th Global Conference for the International Big History Association on the topic of my most recent book on Origins, How the Earth Shaped Human History, which is very much a big history text. But what I thought would be worthwhile right at the beginning, first off, is just to spend a couple of minutes introducing myself and who I am and where I come from, what my background is and how I'm approaching big history. Because my actual background within academia is in biology. I read biological sciences at university and have since then become involved in a very new field of science called astrobiology, which is all about looking into the possibility of there being life beyond the Earth. I spend most of my time thinking about this place here, our next door neighbor planet, Mars, and whether Mars ever offered an environment appropriate for the origin and emergence of life. And more importantly, if Martian bacterial life, Martian microbial life is present, how could we detect it? How could we find what are known as biosignatures, evidence of that life, with our Mars rovers and our probes? How can you design an experiment or an instrument to detect signs of life on our next door neighbor planet? So my research is very interdisciplinary. It's biology mixed with physics and planetary science and geology and chemistry. And alongside this interdisciplinary research that I'm involved in, I also do a lot of public outreach, science communication, engagement, talking about science and technology on radio or podcasts or bits and pieces of television, and also writing. And my previous science book was called The Knowledge, How to Rebuild Our World from Scratch. And this book is a thought experiment. Let's imagine that the world as we know it has ended. There's been some kind of global catastrophe, a doomsday event, an apocalypse, and the vast majority of the human race has disappeared, has died, and civilization has collapsed. But we have survived. What would you most need to know how to do, how to make, how to gather, how to create to not only support yourselves when civilization and supermarkets have disappeared, but actually how you could go about rebooting civilization itself from scratch, the way you would reboot a computer after it's crashed? Could you navigate some kind of shortcut route through this great network of scientific discoveries and technological inventions that built the world that we live in and that we take for granted today, could you accelerate that process second time around if you had to run through history and the process of development once again? And so this book, The Knowledge, is also itself a big history text. It's about human history and human ingenuity and resourcefulness and discoveries and inventions that have enabled us to build the world we live in today, and looking at that process of development. And what so basically it's how to do Minecraft for real. That's why this slide is in here. How to go right back to scratch and gather what you need from the natural world around you and combine it in different ways to make new substances and materials and tools and technology to progress back up that ladder of technological development. And what I've been doing with the new book, with Origins, is pulling out on that perspective even further and looking at not how human ingenuity has enabled us to build the modern world, but how features of the planet itself that we live on, features of planet Earth, and how they have had a guiding, defining influence on the whole of human history. From our very origins as a species in East Africa through the thousands and thousands of years of the development of agriculture and the emergence of civilization and recorded history. How different features of plate tectonics or atmospheric circulation or the availability of different mineral resources and metals around the world had a defining influence on our human story, on big history. And what I wanted to do for you for the next half hour or so was talk through just 2 or 3 of the case studies, of the examples from the book, from Origins, and explain this big history narrative as told from a planetary scientist's perspective, looking at aspects of geology and plate tectonics and aspects of our planet. And so we'll start with one aspect of the distribution of civilizations around the world, and specifically around this spot on the planet, the Mediterranean, this great inland sea that for thousands and thousands of years, through the Bronze Age and Antiquity and the Classical era, has been a bubbling cauldron of activity of different societies and cultures and civilizations, from the ancient Mycenaeans and the Phoenicians and the Minoans and the ancient Greeks and the Romans that we learn about in ancient history classes. But when you think about it, almost all of that human activity has taken part on one side of this oval-shaped inland sea, and on the other side, all that activity on the whole has been on the northern rim of the Mediterranean, whereas the African coastline, the southern lip of the Mediterranean, has on the whole been much more quiet and lacking in activity and civilization. And in order to understand why that might have been, why there has been this great disparity in the activity of civilization for thousands of years of human history around the Mediterranean, we need to look back through our planet's history to see where the Mediterranean came from in the first place. Because it turns out that the Mediterranean Sea today is no more than a mere puddle left behind from what was once a great, vast ocean called the Tethys, an ocean that in its heyday was as large as the Atlantic Ocean is today. So if we wind back that clock of our Earth's history and look to a period in the top left here, around 240 million years ago, around 250 million years ago, in this period of Earth's history, the movement of the continents of our planet, of plate tectonics, have brought all of the great land masses of the Earth together into a single giant supercontinent called Pangaea, the All Land. And held in the cup of this C-shaped supercontinent was an ocean called the Tethys. And over time, as that supercontinent has since broken up and fragmented and been torn apart into the individual continents we're familiar with today, and those have scudded around the surface of the planet, first Africa and then India has ridden back north again and recollided back into the continent of Eurasia and crumpled up lots of mountain ranges like the Alps and Himalaya, mountain range in that process. But also in that reconfiguration, that rearrangement of the continents, the Tethys Ocean, its seafloor tectonic crust, was subducted and destroyed back into Earth's interior. And so the situation we find today with the Mediterranean is that this is just the relic, the puddle left behind from the Tethys. And the important fact here is that it is Africa that is riding north to collide into the southern margin of Eurasia, and Africa is being subducted, it's being swallowed beneath the continental crust of Europe, which has crumbled up these mountain ranges, such as the Alps, the Carpathians, and it's created a very intricate, mountainous, hilly landscape on the northern Mediterranean coastline, which has become swallowed and drowned by the rising of the sea levels to give plenty of islands and archipelagos, as well as a very intricate coastline with lots of natural inlets and bays and natural harbours. The North Mediterranean coastline is ideally set up for seafaring cultures, for seafaring civilizations to travel and explore and trade with each other. Whereas the other margin, the other lip of the Mediterranean, the African coastline, is being subducted beneath the crust and destroyed, and so is therefore very smooth and flat and is devoid of many natural harbours. It's unaccommodating for seafaring cultures. So this feature of plate tectonics and continental drift has had a huge influence on the distribution and the opportunities available to civilizations around the Mediterranean for thousands and thousands of years of human history. This is very much a truism of big history in this part of the world. Now, if we fast forward a bit later into our human story, into the early modern period, I wanted to look now at not how movements of the ground beneath our feet, of plate tectonics and continental drift, but instead I want to look now at the movement of the atmosphere high above our head, the atmospheric circulation, and how that gives rise to the wind patterns around the world, which are very, very important through the age of exploration, the age of sail from the European point of view. And I want to start this story in the early 15th century, a period in history when Europe was backwards, it was isolated, it was undeveloped, it was uneducated. We were, as Europeans, we were right on the periphery of this broad, spreading continent of Eurasia. We were right at the end of the trade routes, such as the Silk Roads that were draped across this continental landmass. We were the last people to receive trade and commodities and goods, but also we were the last to receive everything else that travelled along those overland trade routes. Ideas and philosophies and religions and technologies. The blast furnace didn't arrive in Europe until about 1,000 years after already being developed on the eastern margin of Eurasia in China. And later in the 14th century, by the mid 1400s, as Europe was starting to explore and wanting to look back out into the wider world, it couldn't head east back along the route of those trade routes back along the Silk Roads, because by this period of history, a large Islamic empire had become established. It had taken over Constantinople and closed, the Ottoman Empire had closed the route towards the east for Europe. So instead, it had to look in the opposite direction, towards the west, out into the stormy, tumultuous expanse of the Atlantic Ocean, a region that Europeans had previously avoided and stayed clear of for their better sense. And the stepping stones, if you like, that started drawing European explorers, European navigators out into the Atlantic Ocean were these archipelagos of islands. And most of these are actually the peaks of volcanoes on the Atlantic Ocean seafloor, places like the Canary Islands, the Cape Verdes, the Azores. And the Portuguese started heading down the northwest African coastline and discover the Canary Islands in the process. But if you are in a sailing ship, following the direction that the ocean currents are already flowing, the way that the winds are already blowing to get down that African coastline, how do you get back home again? You can't just turn your ship around and head back the direction you came. You'd fight against the very ocean currents and winds that took you there in the first place. And so the solution that the Portuguese developed was known as a volta do mar, a return of the sea. In order to get back home again, paradoxically, you steer away from the coastline. You steer away from the shore and the safety of that coastline and the access to water and the landmarks you know how to navigate by. And instead, you steer deeper into the expanse of the ocean until you encounter a different set of ocean currents and wind patterns that will blow you back in the direction you need to go by. And when the Portuguese had headed further down the West African coastline, the Volta do Mar, this loop through the ocean that they needed to steer, took them so far out into the mid-Atlantic that they stumbled across the Azores, islands which were previously uninhabited. No human had been there before until Portuguese and then Spanish navigators found their way by steering these loops through the ocean. So what these early European explorers were coming to understand was a global pattern of wind direction and ocean currents that those winds blow around. The first piece of the jigsaw that we came to understand was in the North Atlantic, and we started to piece together this global picture, which we understand today, that you can see in this graphic here from the book, from Origins. And this global pattern of winds is actually pretty simple to understand. We'll start around the equator, where the sunshine beams directly down onto the Earth's surface, warms the ground, warms the ocean surface, and that warm air rises and then cools and then rolls over through high altitude to sink back down to the surface of the Earth. Around the equator, there's lots of rising air masses. There's lots of rainfall, and all the rainforests of the planet are found around the equator. Whereas where the air descends from high altitude and is very cool and dry, many of the deserts around the world are found at about 30 degrees north and south of the equator because of that descending air mass. And then to complete this great vertical circulation pattern, the atmosphere has to return back along the surface towards the equator. And atmospheric circulation over the Earth's surface is just what we call the winds. And so the winds blow towards the equator on either side. And the only other important fact that you need to understand here is that while the atmosphere is circulating these great vertical currents, the entire planet Earth is rotating beneath that shell of atmosphere. And that creates what's known as the Coriolis effect. The winds blowing back towards the equator get deflected to one side. And this means that the winds on either side of the equator, there's a band of wind that always blows towards the west. It's known as the trade winds. And then beyond the band of the trade winds, where the atmospheric currents are circulating the opposite direction, you have a band of winds blowing in the other way, which are known as the westerlies. If you want to explore across an entire ocean, if you want to establish vast intercontinental long-range trade routes, the way to do that is to put your ship into one conveyor belt of atmospheric circulation, blow across the ocean in one direction with the trade winds, and then move north, and then allow the winds to blow you back the other way along the westerlies. And by understanding this global pattern of wind bands and the ocean currents that they also set up, these navigators, these explorers, came to establish some of the longest range trade routes in human history during the centuries of the age of sail. The Portuguese eventually found their way all the way down the African coastline and around the southern tip of Africa to cross the Indian Ocean and find the source of the Spice Islands and all of the wealth that they'd been searching for all those decades of exploration. And it turns out that the only way that you can clear the southern tip of Africa by following the way the winds blow is by steering such a wide loop through the South Atlantic Ocean that you effectively stumble across South America. The reason that Brazil speaks Portuguese, whereas the rest of Latin America speaks Spanish, is simply that is the way that the Portuguese sailors were blown to when they were trying to find their way in the opposite direction towards the east and India. The Spanish found their way across the North Atlantic with Columbus, of course, discovered an entire new continent of North America that they'd not been expecting or anticipating, crossed that landmass, and then became the first the first European explorers to see a vast new ocean on the far side of this new world, of the newly discovered lands of the Americas, which they called the Peaceful Ocean, the Pacific. And the Spanish then established the longest range trade route through the age of sail, which was the Spanish Manila galleon route, where they would start in China, loading up the holds of their ships with a lot of luxury trade goods, things like porcelain, spices. They would sail north to Japan, where they'd find the westerly band of winds, which would blow them all the way across the Pacific Ocean to the coastline of North America. They would then sail along the coast down to Mexico, where the Spanish had lots of silver mines, which they would fill silver coin into the hold of their ships, allow the trade winds to blow them all the way back along the vast breadth of the Pacific, back to China, and repeat that return trip again and again, generating huge profits for themselves in the process. The reason that California was so geopolitically important for hundreds of years, the reason that cities like Los Angeles and San Francisco and San Diego were founded in the first place is simply that is the only place that you can get to after crossing the Pacific Ocean following the direction of the winds. You needed to found cities like San Francisco and a port and a harbor to resupply your ships before they could head back down the coast towards Mexico and Central America. The Dutch, when they got in on the age of sail, were able to find a shortcut across the Indian Ocean, cutting out the Portuguese from the lucrative spice route, the spice trade, by exploiting a particular band of winds in the southern hemisphere westerlies known as the Roaring Forties, a particularly strong band of winds. And it was Dutch sailors following along their shortcut of the Roaring Forties that became the first Europeans to discover Australia. And you wouldn't believe the number of shipwrecks littered along that west coastline of Australia, of the coral reefs along the coastline there, from ship's captains who were using that motorway, that shortcut of the Roaring Forties, but missed their turning off that freeway, off that motorway. They weren't able to navigate precisely enough in terms of their longitude and didn't turn north back towards the Spice Islands at the right point and ended up crashing into the continent of Australia. But arguably, the most significant trade route through the Age of Sail for the subsequent playing out of history was the North Atlantic Trade Triangle. And this trade system was established right in the early days of the Industrial Revolution, where Britain and then the rest of North Europe had worked out how to get machines to make things for us, how to start mass producing useful stuff like textiles and clothing and other manufactured goods and weapons, which they then sailed down that old Portuguese route down the coastline of Northwest Africa, where they then sold those manufactured goods and bought human labor, slaves, people who'd been abducted against their will, thrown into chains, loaded into the holds of these European sailing ships, and taken along that trade winds route to the coast of North and South America, where these people were then forced to work on the plantations in the European colonies of the Americas. Slaves forced to grow plants and crops like cotton, tea, coffee, sugar. And then those raw materials, that those products of that slave labor were sailed back along the Atlantic, along the westerly band of winds, taken back to Britain and North Europe, where we then transformed those raw plant fibers, such as cotton, into manufactured textiles, again using our industry and our machinery, and then sailed those manufactured goods back down to the coastline of Africa, and so on and so on. And so this North Atlantic trade triangle was like a giant economic cog sat right across the North Atlantic, being blown round and round by that pattern of global winds, generating huge profits for its masters, for the slave masters, with every turn of that trade triangle. And we don't just see this pattern of features of the planet in how these trade networks were established. This entire process of the Age of Sail and European expansion and establishing of trade networks and colonization and empire building, that was all established based on this global wind pattern, where which 2 points on the planet were easy to sail between. Where do you need to establish your trade routes? Where do you therefore need to establish your ports and your fortresses? Where do you attempt to colonize? That whole process for hundreds of years of early to modern history came down to something as fundamental about the planet as where do the winds blow, and how does therefore the atmosphere circulate high above our heads. And we can also see this distinctive fingerprint, that the pattern of earth processes, not just in the winds and the Age of Sail, but in the modern world, and how people choose to vote in elections, which leader, which party you might elect or choose to vote for in an election, bears the distinctive fingerprint often of planetary features. And the one example of these planetary influences on the political is in this part of the world, in the southern states of the US, of America. And if I peel off this satellite view of the southern states and instead show you the political map, this is how people chose to vote in the most recent presidential election in the States, but indeed the same pattern is seen back through the decades and the centuries. And much of the southern states in recent times have voted Republican. And the political map, there's a sea of Republican red. But there are some counties that vote Democrat. They vote blue. And by looking at this map, you'll notice that those Democrat voting counties aren't scattered randomly across the southern states. There is a structure, there is a pattern to where those Democrat voting counties are. You can see towards the west, there's a band of Democrat voting counties on either side of the Mississippi River. But very curiously and very distinctively, there's this great arc of Democrat voting counties, this great crescent of blue working its way across several of the states in the southern US. And these Democrat voting counties don't correspond, this pattern doesn't correspond to anything you can see on the ground. There's nothing in the landscape, not a river like the Mississippi, not a line of hills or mountains like the Appalachians that account or could explain for that crescent of Democrat voting counties. And so instead, if we peel off that landscape map and now look underground, look beneath our feet at the distribution of the geology, the distribution of rocks beneath our feet, which are, let's say, 75 to 80 million years old. On the map there in shades of grey, I've shown the distribution of rocks beneath our feet, which are about 80 million years old. And now if I layer back on top the political map, on top of that geological map, you can see this astonishing correspondence between the political and the geological. People are voting Democrat if they happen to live on top of that band of 75 million year old rocks. And this makes no sense at all. These people aren't geologists. They're not going out into their backyard, digging a hole, drilling a borehole, dating the rocks underground and going, the rocks here are 50 million years old. That means I'm going to have to vote for Donald Trump or the Republicans versus Democrats or Hillary Clinton or Joe Biden. There's not a direct link, of course, from the rocks to people's political preferences. But what there is a long chain of cause and effect, of one thing leading to the next, stretching across hundreds of years of human history and then back through millions of years of planetary history. This is a great example of big history in operation today. And what accounts for this voting pattern is due to the fact that 75 million years ago, the chapter of Earth's history back then was known as the Cretaceous period. And during the Cretaceous, the sea levels were much, much higher than they are today. The ocean lapped right up through the center of North America in a great inland ocean known as the Interior Seaway. And so the rocks laid down across large areas of America back then were effectively compacted seafloor mud. Those became buried by subsequent strata of rock. They became compressed and converted and transformed into rock, and then re-eroded and exposed again today along this particular band of 85 million year old rocks. And when those particular rocks are eroded and turned into soil, they create a very dark, rich, fertile, packed full of nutrients form of soil. And it was realized in the mid-1800s that very dark, rich soil was incredibly productive for growing cash crops like cotton. Crops which are very fiddly to try to harvest. You have to use your fingers. You can't reap it like you might wheat. It's very fiddly to try to harvest cotton. And as we've already seen, unfortunately, in that period of history, slave labor was used. People were taken from their homes on Africa, borne across the Atlantic on the trade winds and forced to work on the plantations in the Americas. And even today, hundreds of years after the Civil War, after the abolition of slavery, after the civil rights movement. Still today, one of the greatest concentrations of Black African Americans living are still along that arc of Cretaceous age rocks. People who unfortunately still today suffer from socio-economic issues of poor job opportunities, poor salaries, poor healthcare, poor education, people who are much more likely to vote for Democrat ideals and Democrat political promises rather than Republican Party promises. That's what accounts for this Democrat arc of voting. And actually, the city that I've marked on the map here of Montgomery is the place where in the mid-1950s, a woman called Rosa Parks, a Black woman called Rosa Parks, refused to give up her seat to a white gentleman on the bus. And so the entire civil rights movement, the entire epicenter of the civil rights movement began smack in the middle of that band of 75 million-year-old rocks. There's this long chain of cause and effect going from politics and sociological issues and economics through agriculture and the means of production to the soil type, through the geology, through to planetary processes, stretching back over hundreds of years of human history and then millions of years of our planet's history. There's this deep, profound link from features of our planet through to human history. And just to demonstrate, I haven't cherry-picked the only example around the world where there is this deep link between the planetary and the political. Here is an example from where I live, in Britain, in the United Kingdom, where on the left-hand map, I'm showing you in red constituencies that in general elections tend to vote for Labour, the main liberal left-wing political party in Britain. And on the right, there's a map showing the distribution of rocks beneath our feet, which are about 320 million years old. And again, you can see this astonishing correspondence between the political map and the geological map. And the explanation behind this is actually much simpler. And it should be apparent to you when I tell you that the chapter of Earth's history 320 million years ago was called the Carboniferous. These regions in red on the right-hand map are the great coal fields of Britain, which sparked and helped trigger the Industrial Revolution, helped power machinery. And the more recent step in that chain of the argument is that the Labour political party was born out of trade unions to do with the coal miners. That's the final step in that chain of cause and effect in this particular example. Now, I've only had about half an hour or so to cherry pick some of my favorite examples of these examples of big history from the book Origins. There are plenty of other examples in the book, such as why do most of us eat a bowl of cereal or a bowl of rice or a slice of toast for breakfast, or indeed every meal of our lives? Why are these cereal crops, such as wheat, maize, rice, barley, become the staple crops, the staple crops to feed all of humanity through all of the history of civilization? How did the feature of the planet decide even what we choose to eat? How did Holland's drowned landscape create capitalism and the modern financial system? Why did the Great Wall of China follow what is fundamentally an ecological boundary across Asia? And if you want to find the answers to these questions, I've mentioned there's the book that I wrote, Origins, How the Earth Shaped Human History. I've shown on this slide the covers of several of the other books that I've written, including the one I mentioned right at the beginning, The Knowledge, How to Rebuild Our World from Scratch, which this thought experiment about how you could reboot civilization after some kind of apocalypse. But if you want to read, without having to buy anything, some of this big history narrative that I've been talking to you about just now, I've just published in a collected book called Expanding Worldviews, Astrobiology, Big History, and cosmic perspectives. I've published a chapter in that book telling a similar story to some of the parts that I've been talking about to you this afternoon, about planetary dynamics, human genetics, big history, which you can download and read as a free PDF on my website, which you can see down the bottom right there, is lewisdartnell.com. And I've also made available off the back of this book, off the back of Origins, a set of educational resources, which are also completely free, which you can access on the book's website, teachers.originsbook.com. You can download links to teaching curricula, many of the figures and graphics that I created myself for the book and for this presentation. You can download and use yourself by accessing them from the website here. But thank you very much for listening. I hope that this talk about big history from a planetary perspective has been of interest to you. And thank you ever so much once again for having me along for the International Big History Association Global Conference. Thank you.
Thank you so much, Professor Dartnell. I was so interested in the lecture that I didn't realize that it had ended, and it's only when the screen came up I came out of the world that I had gone into after looking at your video. So we have questions from the audience. I think we can, if you think we can take them first. Okay.
Yeah.
So we have a question from CK. It's a long question. It's in parts, so I'll just read it out. It says, can we display it in parts on the screen? Yes. So it says, a very interesting talk. I'm amazed. Just another perspective on how the geological fundamentals of the Mediterranean Sea has shaped the European history. Thus, the tranquil sea surface not only helped the southern Europeans to be great seafarers, but it also helps them to trade with the ancient Egyptians and the Mesopotamians. So they develop alphabetical language to make sense of Egyptian and Mesopotamian pictorial language. The alphabetical language, in turn, facilitates logical thinking, which can't. Then he is asking you that can't shape logical thinking. So he's asking you, does that make sense to you?
Yeah, so it's a very good point that one of the other important aspects of the Mediterranean Ocean, the Mediterranean Sea, is that because it's enclosed, it is also effectively non-tidal, that there are no tides in the Mediterranean Sea. And where I am right now is in the south of France, Provence, right on the Mediterranean coast, and there is no variation in the level of the sea at all, which makes it very easy for ports and harbours, for example, in the Mediterranean. So it's very calm in that sense, but you certainly do get very bad storms in the Mediterranean as well. So in a sense, the Mediterranean is ideally set up, as I explained in the talk, for seafaring and for trade, although it's not effortless. It's not perfectly safe because there are still storms and you can lose your shipping. But because it's a relatively contained area, it's easy for different cultures to communicate with each other, share languages, share writing systems, as we heard from the question from Tanchi. The alphabet that we use around Europe today has effectively been inherited from the Phoenicians, who were expert seafarers and traders across the entire Mediterranean region. So I think that the general take-home message here is that in parts of the world where seafaring is easy, it allows you to communicate and trade over much greater distances more easily than over land. And that is then creating a melting pot of ideas and philosophies and knowledge. But that's not to say that the Mediterranean was the only place where this happened. And of course, something I've not really spoken about in that talk just then was the Indian Ocean and Southeast Asia, where the wind system there is very, very different. It's particular to that part of the world, which of course is the monsoon wind system. And as I explained earlier, around the entire planet, you have bands of winds that blow in different directions. So to cross an ocean and then come back again for trade, it's a problem moving your ship back and forth across distance. Whereas in the monsoon system of the Indian Ocean, it's a problem of choosing your timing of when to sail in one direction and then the other, because the wind direction periodically reverses. So the Mediterranean was a hubbub of oversea trade and communication, and so was the Indian Ocean and Southeast Asia as well, around that archipelago of islands.
Thank you. That was one question which I was going to ask you, but you already answered that about the Indian Ocean, as to what kind of a picture that we see regarding the Indian Ocean here.
Yeah.
So we have another question from Chiara, Stefano, and Tobia. You pointed out very interesting connections. How strong is the verb shape in this analysis? How do you think the effects you explained along the continuum of accident, light, influence, strong influence, determinism?
Yeah, it's a very good point. And I think when you're telling narratives like the ones I explore in Origins, is to not fall into the trap of geographical determinism. I'm not saying that things in history had to turn out this particular way. It wasn't, foreshadowed millions of years ago. There is a lot of contingency, there's a lot of randomness, there's a lot of opportunity for history to take in different directions. But to pick one particular example, in our particular history, for whatever reason, it was European navigators that first crossed the Atlantic, crossed the Indian Ocean, crossed the Pacific, to then start building empires and sort of colonial expansion. But it's not necessary, it's not guaranteed that it would be in Europe as this tiny little peninsula on the edge of the entire continent of Eurasia. It could have been Indian explorers, it could have been Chinese explorers. In fact, it was almost very, very nearly China that discovered Europe, rather than vice versa. With Cheng Hei's discovery and treasure fleets. But the point I'm making in Origins is, regardless of which culture, which civilization establishes the long-range trade route across the Pacific, for example, they will have to establish it in the same place, because it is a fundamental property of the planet to do with atmospheric circulation where the wind bands are found. So if it was China crossing east across the Pacific, the Californian coast would have been just as important to them as it was to the Spanish, because of these universals and fundamentals of the Earth. And then, as I gave in the example of the politics, on top of those foundation and base levels of planetary explanations, you get the sociology, you get the economics, you get the contingencies of history. So the details might have been different, but the fundamentals would have been the same if we reran history at another time over.
Thank you, Professor Dartnell. Now we have a question from Professor Hirofumi Katayama. You argued that the Earth shaped our history. Do you think this is also applicable in the Anthropocene?
Yeah, again, it's another really good question. And basically, chapter 1 of Origins, I introduced the Anthropocene and this idea that nowadays, as a species, humanity has become so incredibly powerful, with a profound influence over the entire planet, over global processes, in terms of changing the climate, changing the chemistry of the atmosphere, acidifying the oceans. Human activities are now mining and quarrying and moving around more earth, more ground than the rivers of the world. So humanity is now a geological force greater than natural geological forces in some contexts. And with that great power, of course, comes great responsibility. And these are the problems that are on our doorstep right now that we are going to have to try to solve if we have a future of civilization in the coming decades and centuries. But I think many of us are already quite familiar with that side of the story, about how humans are having a profound influence on the environment on the Earth today. But I think what is much less appreciated is the flip side of that same coin, that before the Industrial Revolution, the sort of the river flowed in the opposite direction, and it was the earth that was having profound influences on us and our evolution and our historical development. But you are absolutely right that that relationship is flipping now with human technology and industrialization.
Thank you. Next, we have a question from Rashida Athar. She says, "Thank you, sir, for a wonderful presentation. What could be the reason the British were successful over French and Portuguese over colonizing India? Also, is it possible to see any voting pattern of India and its geography? Thank you."
So I've not looked specifically into voting patterns in India. Perhaps I should have done before doing this big history talk based in Pune, based in India. But I would be surprised if there wasn't any influence of soil types, terrain type on voting patterns in different regions of India. I gave examples in the southern states of the US. I gave the example in Britain. After I was on book tour in Australia, a geologist there told me about a really interesting pattern around the city of Melbourne to do with low-lying flat terrain and more rugged hilly terrain, to do with the social classes of people that lived in different places and where the factories were built, and therefore which political parties people tended to vote for. So again, to make the point very clear, I'm not saying that geology directly influences who people vote for, but there is a chain of cause and effect of one thing leading to another that does help shape and influence our political choices today. But in terms of the colonization and then empire building of the European nations from the 1500s, 16, 17, 1800s, there was, of course, this great contest between the European seafaring nations, between Portugal and Spain in the early days, and then with England catching up, Britain catching up, as well as France, and then Germany, and then the Netherlands. And I think in terms of Indian colonization, Portuguese were there long before Britain arrived, with Vasco da Gama establishing the first European trade route across the Indian Ocean. Although, of course, I stress Indians and Chinese and Southeast Asian navigators were doing it for hundreds of years before Europe came round Africa to reach the Indian Ocean. And that has more to do with the economics of the time and the strength of the Royal Navy, that sort of Portugal and Spain had peaked and then started to recede as world powers before England and Britain came onto the scene, and then started empire building in India.
Thank you. So this is, we have one question, and this will be the last one that we will take this session because we are on a strict schedule. So we have a question from Nagarjun Ji. Curious indeed that the current debates on the climate changes is indeed a central political agenda, often becoming a debate between the conservatives and others. Curious to know about your comments on the current climate debates.
Yeah, this is a very, very big issue, very big area, and of course, very, very important as well. As a scientist, I believe that the evidence is very clear, very strong, that climate change is happening right now, and that it is caused by human activity, by industrial processes, by releasing of carbon dioxide and other greenhouse gases. And in just the last couple of weeks, we've seen very widespread flooding around the world. China was hit particularly badly. Canada and the northwest Pacific coast of America has broken climate record after climate record after climate record, with numerous heat waves and then forest fires, wildfires sweeping through afterwards. It is undeniable that climate change is happening already and is directly impacting human life and our cities and our way of living. And so reasons to deny that is happening are almost certainly politically motivated, whether you work in a particular industry that might suffer if the economy starts shifting in different directions. But from what I understand, it's not like we all need to make a huge sacrifice to our lives. We have got a lot of technology already that we need to solve this climate change problem, whether that is renewable energy sources such as hydro, wind power, solar power, trying to solve the fusion energy problem. We're making progress there. The point I always make is that the problem of climate change we're facing today is effectively the unintended consequences of a solution to a previous problem, which is Britain and North Europe running out of energy, running out of forests, basically, in the late 1600s, early 1700s. And we realized we could dig up coal and burn that. So that has created the problem of climate change as an unintended consequence of our ingenuity and technology. So I have every confidence, every faith that that same ingenuity and technology can be applied to solve this problem as well, and then get us to the next step of development.
Thank you so much for answering the questions so wonderfully. I'm sure that everyone has a lot of questions. Even I have a lot, coming up in my mind, and you have certainly given us a lot to think about. I am already planning a lot of things for my class based on what what you have said in your lecture today. But as I said, unfortunately, we are our time here is ended. We do have table conversations where people can join you and ask you questions on the table. So thank you everyone for joining us, and thank you, Professor Lewis Dartnell, for joining us. Thank you.
Thank you very much for having me. Bye-bye, everybody.
Okay.